Hey guys, welcome back to this video. So this is probably like the last experiment that I'm going to be doing, mainly because I'm going to be starting another new channel and all that stuff. There's like so much work for that, plus academics and all that crap. So welcome to this video. In this video, we're going to be doing half adder and full adder, and half subtractor and full subtractor. So unlike the previous circuits that we simulated, this one has logic gates that we're going to be using, and it has a digi clock or dig clock, whatever it is. And we're going to be using those to get our desired outputs. So I'm just going to go ahead and create a file, uh, project adder and subtractor. Okay, up, and we create a blank project. Okay, so we go ahead and we place the parts. So there's a common misconception that digiclock is basically digiclock. So it's not that, it's digclock. There's no I after G. It's just dig. Okay, and we use the source, dig's clock source, place two of them in parallel with each other, and after that we place the logic gates 7486 and 7408. It's too big. Okay, so basically the output that we get out of here is the sum, and the output that we get from here is the carry. Okay, so I'm just going to go ahead and wire them up. This goes here, and let's take another node from here and connect it to 7408, and from the second one connect it to 2. Do the same thing over here also. Okay, yeah, and it's such a basic, I mean it's really a basic circuit. We don't actually need to do much. Yep, this is just for your convenience. You can do this, or you can just chuck it and just place the voltage probes over here itself. So we're going to set the run to time is 2 milliseconds, 2 milliseconds again, on time also. I mean, sorry, off time and on time is 2 milliseconds, not the run to time. Off time and on time is 2 milliseconds, and just leave the rest as it is, and make this 1 millisecond. 1 millisecond. Okay, that's it. So that's basically your circuit. Then you just have to go to the analysis, like new simulation profile, just write some random like adder, okay, whatever it is. Really, no one gives a shit about this. So for the run to time, make it 4 milliseconds, because you're going to be generating first, like first you're going to be generating for 2 milliseconds. The first digiclock is going to be generating zeros, and for the next it's going to be generating 1. So make it 4 milliseconds and hit OK. Well, and now you have to just place the voltage probes here, over here, here. Make sure that you place in the same order, because then you'll have an idea, like when you get the output, you'll have an idea whether your simulation is correct or wrong. So let's run this. Okay. Yep. So I'm getting this. So let's compare it with the truth table. For the truth table, here we have the truth table, and here's the simulation. Oops, it's too small. Okay. Yep. Okay, so well, these two are basically the inputs. So if you see for the first 2 milliseconds, it's 0. So let's see, 0 0 over here. So let's take the first millisecond. It's 0 0 0 0. Okay, so what are we getting here? 0 0 0 0. Okay, and for the second millisecond we're getting 0 1 0 1. So it's 0 1. Oh, it's 1 0 because over here the carry is 1. So basically this is the carry. Okay, u1a is the carry and this is the sum, and we're getting 1 0 0 1. So we're getting 1 0, the sum is 0 and the carry is 1 here for the third millisecond, I mean 2 to 3. And for the last 3 to 4 we have 1 1 1 0. So if you see the input signals, it's 1 1, and the sum is 1 but the carry is 0. I think I'll enlarge it also. Yep. Oh shit. Yeah, so if you see this, it's like this is basically the waveform that you're supposed to get, not the waveform, the output. Okay, and yeah, that's basically half adder. So we're going to be doing the full adder now. So we can just go ahead and remove these probes over here. Okay. Yeah. So I'm just going to be showing you guys. No, before we go to that, I think it's better I show you guys half subtractor, because it's almost a similar. It's the same thing. You just have to add another component. So you place 7404. This is a NOT gate, so I'm going to be placing it over here. Just remove that. Try to extend this a bit so it doesn't look like really cramped up. Yep, and then you just connect these two terminals, these two. Um, so it's the same simulation profile, everything is same. I mean, even the value is the same. So let's just go ahead and place them. So let's simulate it. Run. Yep. So this is what we get. Let's check if our output is same as, I mean, like whatever we're getting is same with the truth table. So I'm just gonna go to the truth table, this one. Okay. Yep. Yeah, so basically we can just chuck the first A and B, whatever we're getting. It's just 0 0 0 and 1 1 0 1 0 1. Okay, now if you see, you have 0 1 1 0 and 0 1 0 0. So 0 1 1 0 corresponds to D over here, and 0 1 0 0 corresponds to B naught. So, well, our value is the same as the truth table, so just we have simulated the correct circuit. So all the connections are correct. It's pretty much it for an half adder as well. I mean, sorry, half subtractor. Now we're gonna just go ahead and simulate a full adder. So for a full adder, you can remove the 7404. It's not needed in a full adder. And, wire these 2 points. Remove these nodes, the probes. Sorry, not the nodes, the probes, and just keep removing them and try to just a little bit towards it. Okay. Yeah. No. So we're gonna since it's a full adder, for this we need 3 inputs. So let's place another digclock. Okay, it's the wrong one. Come on, man. Yep. So place another one. Um, and we have to change the on time and off time. So let's make this 4 milliseconds because there are 3 inputs. 4 milliseconds, 4 milliseconds, 2 milliseconds, 2 milliseconds. And you make this one as 1 millisecond. Okay. And well, you need 2 more sets of 7486 and 7408. So 486. Place it over here. Another 7408. Okay. So for this, so in this, what you're gonna do is basically you're gonna wire up these two terminals. It's pretty hard to memorize a full adder circuit, so just connect these two, connect this, no, not this, sorry. Connect this to point 2 over here, this one to point 1. Connect this as well to point 2. Okay. So you've done most of it. There's one more logic gate that we're going to be needing in this. So let's just go ahead and place it. 7, 4, 3, 2. Yeah. So we're going to be needing this as well. It's just an OR gate. So we connect this to this one to this. Yeah. Okay. So the circuit is done. We're just going to go ahead and place the voltage probes here, 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 and at the output as well. Okay. And one more thing that has to be changed in this is the simulation profile. You're going to be simulating it for 8 milliseconds this time because your the digiclock with the highest value is like 4 milliseconds. So for first half, it's going to be generating zeros in for like 4 milliseconds and then ones for the next 4 milliseconds. So we just go ahead and run it. So when you run it, you get an output like this. Just chuck these whatever like labels over here because it's like super crazy. I get different label every time. Okay. So I'm just going to go ahead and show you guys the what do you say, the truth table. Oh, great. It's too hard, I guess, to show everything. Okay. If you notice over here, for the first like 4 milliseconds 0 and this like 0 1, it's like 0 1 0 1, so we can just like chuck the first three. Now if you notice this 0 1 1 0, so basically that's like the carry. So it's like 0 1 1 0, then it's like 0 and 0 1, then it's like 0 0 1. That's the carry. Like U3A Y is like the carry, and the sum is basically U5A Y. It's like you're getting 0 0 0 1, 0 0 0 1, then you're getting 0 1 1 1. So you're getting like 0 1 1 1 1 1 1. Okay. So the values are verified with the truth table, so our circuit is correct. And if you want like the enlarged version of it, this is how it looks like. This is the signal that you can expect for a full adder. And now I'm just going to go ahead and simulate a full subtractor. For that, you just have to make some minor changes like how you did it in like half adder to half subtractor. So I'm just gonna do it from scratch because it's pretty hard to change it in this itself. So like, let me just remove everything. Oh shit, delete. Okay, so we just need digiclocks first. Clock. So 3 sources, 1, 2, 3. Okay, and we need a 7486 logic gate. Place one here, another one over here. Uh, just chuck that. Okay. Now we're gonna need a 7408. Okay. Place one over here. Okay, and another one over here. And we need 7432 as well. 7432 over here. And we need NOT gates like 7404. Yeah. Here. Yeah, so we have placed all the components. So I'm just going to go ahead and change the values of the digiclock before I start connecting them. Make this 1 millisecond. 1 millisecond. This one would be 4 milliseconds. 4 milliseconds. This one will be 1 not 1 millisecond, 2 milliseconds, and 2 milliseconds. Okay. So we have to connect everything up now. So I'm just going to show you guys how to do that. First, connect this 1 millisecond to this one over here. Should have placed it properly. Yeah. Okay. Next, connect this to this, this to this, this to this. Okay. Move this a little bit downwards. Okay, and wire it up. Yeah. And connect this to this terminal over here. Okay, and take another one from here and connect it to one. This will be connected through the NOT gate to this, and this would be considered as an input to this from here to this. So circuit is done. We have to place the voltage probes now. Place one here, another one here. No, before you do that, just place in an order. So you get like 4 milliseconds, then you get 2 milliseconds, then 1 second. Okay, and at the outputs, yeah. So the circuit is done. Let's just go ahead and simulate and see what we get. Okay, run. Yep. Oh shit, I must have not connected something. Oh, forgot about this. Just connect this to this. Yeah, done. Okay. So the circuit is done. Let's just check, our values with the truth table. Okay. So as you can see, for the first signals like 0, 0, 0, 1, 1, 1, 1. second one is like 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. It's the third one. Okay. And as you notice, D over here is like 0 1 1 0. So if you see the first 4 milliseconds, like 0 1 1 0 0 1 1 0, and the next 4 milliseconds is like 1 0 0 1. So 1 0 0 1. And if you notice B naught, it's like 0 1 1 1. So for first 4 milliseconds, like 0 1 1 1. Next 4 milliseconds is like 0 0 0 1. So it checks out with the truth table. So our simulation is correct. It's a circuit. If you want to show you guys the thing again, this is like for the full subtractor. Full subtractor, this is what you're supposed to get is your output. Um, that's pretty much it. Thank you for watching my last video. And no need to like, share, or subscribe, I guess. Okay, thank you guys.